So, the question tells us there is a scanner. This scanner can scan people to tell you whether they are an upstanding citizen or they are a terrorist. Let me introduce some nomenclature so we can solve the problem in a systematic fashion. I will say the person P, which is a random variable, can hold two values, C or T. T being the terrorist and C being the upstanding citizen. Similarly, when the scanner test is done, this random variable, the result of the scanner test, can also hold those two same values, C, the upstanding citizen, or T, the terrorist. We are also told to write down mathematically that the probability of S equal T, so the probability that the scanner test says the person is a terrorist, given the person is a terrorist, is 95%. Similarly, the fact if the person is actually an upstanding citizen, the probability that the test will say they're an upstanding citizen is also 95%. This is equivalent to saying there's 5% chance that an upstanding citizen will be diagnosed as a terrorist by the scanner. That's quite risky. Okay, we are finally told that in this plane there are 100 people and there is exactly one person who is a terrorist. So the probability that a person P is equal to T, a terrorist, is 0.01. So we have this plane, and we know that the person tests positive. The person sitting next to you tests positive specifically. That in itself is quite irrelevant, that they sit next to you. So mathematically the question we are being asked is, what is the probability that that person is a terrorist, given that the scanner test says they are a terrorist? So that's the reverse to what we have seen so far, where the given is usually with respect to the person. Now is with respect to the scanner test result. We can use Bayes' rule. If you remember, probability of A given B can be written using Bayes' rule as probability of B given A times the probability of A divided by the probability of B. So applying that here, we get this equation is equal to this, what looks like a mouthful. But as you may notice in the numerator, we can actually evaluate every single term. But this is not true for the denominator. The more perceptive ones among you may realize that the denominator is a marginal. And we know that a marginal can be expressed as a summation. So in general form, it can be expressed as a summation of a joint probability with some other random variable. So y in this particular example. So the random variable we will introduce for S as the second variable to do a summation over will be P, the person, which can hold two different values, C or T. So the denominator has now been expanded to account for that. And voila, every single term in this fraction is known, because we can just look at the values on the left. And subbing them in, we get this expression, and if you just type that into your calculator, you will get 0.161. So the answer is, if the scanner says this person is a terrorist, there is actually only 16.1% chance that they are a terrorist, which does seem quite counterintuitive, but that is why probability is important. That is that for this time.